Hey everybody, so we're going to do the Dragster example problem to get you set up to learn how to solve problems using the kinematic equations. So a dragster is kind of like a race car, but the point is just to go really, really fast and accelerate really, really quickly also. Our dragsters, when they race, they just race in a straight line. And they always start at rest. So I'm going to say V1 equals 0 meters per second. In part A of our problem, the dragster is going to speed up. It could reach a speed of 98 meters per second. So that's our second velocity mentioned, V2. Once it hits its top velocity of 98 meters per second, a parachute is programmed to deploy. Dragsters go so fast that you would literally need like an airplane type of space to bring it to a rest without a parachute. Its brakes will help somewhat, but a parachute will give it the negative acceleration it needs to come to a full stop in a reasonable distance. So finally, at the end, the problem doesn't say it, but it doesn't say it reaches a speed of 0 at the end. However, it does say that it comes to a stop. So we assume that at the end, it comes back to 0 meters per second. Alright, so A and B are really separate example problems, two example problems that I put into one, and we're going to treat them separately. The speed up and the slow down will be treated as separate problems. So in the speed up part of the problem, we want to know what is the positive acceleration of that dragster, what's it able to achieve with its gas pedal there, right? So to start any kinematic problem, you got to list your 5 givens here. VI, VF, A, T, and D. VI, at the beginning of its speed up section, it starts at rest, a velocity of 0. Everything starts at rest. It has an initial velocity of 0. At the end of just the speed up portion, not the speed up and slow down, at the end of the speed up portion, it reaches a velocity of 98 meters per second. So that's its final velocity. Acceleration, we're trying to look for that. What's the acceleration of the dragster? And they tell us it accelerates in 6 seconds. Distance, how far it goes while it is speeding up, is not mentioned, nor is it asked for. And that's kind of a clue if you remember your kinematic equations notes. The variable that is not asked for nor given is your missing variable. So in this case, in the speed up, it is distance. So we know we're going to use the second equation. VF equals VI plus AT. We can plug in 98 equals 0 plus A times 6. So we can say 98 equals 6A and divide both sides by 6. And we've got an acceleration equal to positive 16, I believe. Let's do it on our calculators here. 98 divided by 6. Yeah, 16.33 meters per second squared. Great. So there's the speed up portion of your problem. Now think of B as a separate problem. It starts when the dragster deploys its parachute. So we're just looking at the slowdown section here. Think of it as a whole new problem. And every problem, again, we start by listing our givens before we choose an equation. Now at the beginning of the slowdown, right when the parachute is deployed, is when the car has that 98 meter per second velocity. It comes to a stop at the end. So it reaches 0 meters per second as its final velocity. Anything that comes to a stop has a 0 meter per second final velocity. Anything that started at rest has a 0 meter per second initial velocity. So beware of the stop and rest when you're doing a problem. They're not going to tell you 0, you have to infer it. Okay, so they tell us that it has a pretty hefty negative acceleration rate. Good thing, because it has that parachute on it. Negative 20 meters per second squared. And it wants to know, well, how far of a piece of road, of a strip, do I need to get to a stop? What do the builders need to build? So this calculation would support their design of the drag strip there. It doesn't tell us how much time that it takes to come to a rest, nor does it ask how much time it takes to come to a rest. Therefore, we know time is our missing variable, and it will help us choose an equation. When the missing variable is t, you choose your fourth equation. Vf squared equals Vi squared plus 2AD. Very good. Now you can plug in and solve. 98 equals 0 plus 2 negative 20 D. Alright. Sorry, that 98 should be squared there. The 0, did I make a boo-boo? I think I did. I think I mixed up my initial and final velocities. So let's re-plug in again. 0 is my final velocity. 0 squared is still 0. 98 is my initial. Plus 2, negative 20d. There we go, that's correct now. So we could write 0 equals 98 squared. I don't like to look at squared. We'll just do 98 times 98. What does that get us? It is 9604. 20 times 2. In fact, it's a negative 20 times 2, so it turns it negative. Negative 400d. I'm going to bring that 400d over to the left side of the equal sign and add it to either side. Alright, cancels right there. And let's shift this down just a bit so we can see the bottom. So we get 400d equals 9604, and you're going to be good to solve at this point. Divide both sides by 400, and your distance is equal to 9604 divided by 400. You're gonna get a 24.01 meter strip is needed to bring that car to a rest. Good thing it has the parachute, that way it comes to a stop very quickly with that pretty hefty negative 20 meter per second squared acceleration. Slows down very quickly, that means. Alright guys, so this is 2 example problems basically put into one in order to solve kinematic equations problems. You're going to solve a bunch more right now, so go back to the Dragster example problem. Look right below that, and there's going to be a link to solve the rest of the problems.